Section 1.7, combinations of functions and composite functions. For today's video, we will focus on the first part, the combinations of functions, and in the next video, we'll look at the composite functions. So what we're looking at today is finding the domain of a function. We're going to combine functions using the algebra of functions, specify the domains. And then in the next video, we'll look at form composite functions, determine domains for composite functions, and write functions as compositions. So in general, finding a function's domain, it says if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. Exclude from a function's domain real numbers that cause division by 0 and real numbers that result in a square root of a negative number. Right now we are just dealing with real numbers, which means you cannot take a square root of the negative because then you end up with an imaginary number. All right, so for example, finding the domain of a function. Find the domain of the function g of x is equal to, we have 5x divided by x squared minus 49. Now, if we're talking about domain, we're looking for all the possible values that we could plug in for x. So in this case, we want to know where we'd have any limitations. What two limitations do we need to look for? It tells us right here, we're going to exclude from the function's domain real numbers that cause division by 0 and real numbers that result in a square root of a negative number. So we have two limitations. One is division by 0, and the second we have is a square root of a negative number. Those are the two exclusions that we have from our domain. So if we look at this example, we need to make sure that whatever is in our denominator, that cannot be equal to 0. So in order to find out what has to be excluded from our domain, it says because division by 0 is undefined, we must exclude from the domain the values of x that cause the denominator to equal 0. So if we were to take an x squared minus 49 and set that equal to 0, we can add the 49 over, so x squared is equal to positive 49, and to undo a squared, we could take a square root, and that means x is going to equal positive or negative 7, but these are not going to be that they're equal to it. That's what's going to make that denominator 0, which means those are going to be exclusions. So technically, x cannot be a positive 7, and it cannot be a negative 7. So we will exclude 7 and negative 7 from the domain of g, which means that our domain is what? Well, every other number except for 7 and negative 7 are going to work. So in general, if you think about that, I'm just going to go to a number line real quick. If I have a negative 7 and I have a positive 7, negative 7 is not a solution, positive 7 is not a solution, but every other number on that number line is going to be a solution. That means we're going to use that interval notation. So we're going to go from negative infinity up until but not including 7. So we're going to have negative infinity up to a negative 7. We have those parentheses because we are not including it. We are going to unite that with the next section goes from negative 7 to positive 7. So we're going to go from negative 7 to positive 7. And then we're going to unite that with that last piece is going to go from positive 7 up into infinity. Positive 7 up to infinity. So that is what our domain is. We cannot have 7, we cannot have negative 7. So written out in that interval notation means everything else except for negative 7 and positive 7. The next piece talks about the algebra of functions. So sum, difference, product, and quotient of functions. What happens when we add, subtract, multiply, and divide functions together? So it says let f and g be two functions. The sum f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are the functions whose domains are the set of all real numbers common to the domains of f and g. Now they have this really funny looking notation. It has the domain of f with the intersection of the domain of g. That's what that means, right? Remember that N, it kind of looks like an upside down N. That's an intersection versus the U was a union. So we have to find out the domains of F and the domains of G, which are the domains of F intersected with the domain of G. So we need to make sure that our domain is going to work for these functions. And it says it's defined as the followed. So the sum, we have an f plus g and then times x is the same thing as f of x plus g of x. The difference f minus g multiplied with x is equal to f of x minus g of x. F times g of x, f times g and then times x is your f of x times your g of x. And the f divided by g with the x next to it is your value of your function f of x divided by g of x, as long as g of x is not equal to 0, because remember, division by 0 is not allowed. So let's try one. If we were to combine the functions, it says let f of x be an x minus 5 and g of x equals an x squared minus 1. Find each of the following. So we have part A, we are going to go about adding the two functions together, and then in part B, we're going to find out what the domain of that is going to be. So if we have f plus g of x, they told us that means we have whatever f of x is that's going to add with whatever g of x is. So f of x is an x minus 5. So we have an x minus 5 that we're going to add with our g of x function, which is an x squared minus 1. Now, in regards to my parentheses I put in, I usually use parentheses when I take something out and I replace it with something. I use those parentheses to remind myself to check for any distributive property or if I end up having to square something later on. In this case, the parentheses are not necessary, which means we can just combine any like terms we have. So if we simplify this down, we have an x squared, but that's all we have is just an x squared. We have a plain x, so we're going to have plus x. And then we have a minus 5 and a minus 1, which together is going to give us a minus 6. Now that's what our new function is once we add those two functions together, and then they want to know what's the domain of that. So it tells us we have to look at three things. We need to find the domain of f of x, we need to find the domain of g of x, and then the domain of that piece that we just got. So if we look at the domain of f of x, so an x minus 5, are there any limitations to an x minus 5? There's not a denominator that I have to check for exclusions. There's not a square root of a negative. I don't need to check for exclusions. That means that there are no restrictions. If I then look at my domain of g of x, I have an x squared minus 1. Is there any limitation to an x squared minus 1? Well, there's no denominator. I'm not taking a square root of what could be a negative. So in this case, there's also going to be no restrictions. If I look at my new function, my f plus g times x, is there any limitations with an x squared plus an x minus a 6? If there's no limitation and no restriction on f, and there's no limitation or no restriction on g, there's probably not going to be much limitation on an x squared plus x minus 6. So what is our domain going to be? Well, every number that's from negative infinity to positive infinity.